Okay, so this here is a balance that we use for measuring the masses of different things in the laboratory. And with the balance, what you will notice is that the precision goes to two places after the decimal point. So right here, for instance. So we can say plus or minus 0.01 grams is how we can make our measurements of mass using this particular balance in the laboratory. So before we put anything on the balance, we want to make sure that we zero or tare, T-A-R-E, our balance. So we hit that button and it brings everything to 0.00 grams. So once we have our balance zeroed, we can go ahead and weigh our substances. So one of the things that we need to weigh here is a 50 milliliter beaker. So once we have our balance zeroed, we're going to open up our lid and we're just going to place our 50 ml beaker directly on the balance pad, and we can record the mass of whatever it is that we're recording. In this case, it's the 50 ml beaker. So remember that with the balance, we can go to the 100th place. So for example, this beaker is 29.04 grams plus or minus 0.01 grams. So remember, the last digit in any measurement is our uncertain or our estimated digit. And with this instrument, that is already built into our measurement. So the masses of the things that we will need to weigh out will be measured, and they'll be recorded and provided to you in a data document. Okay, so one of the things that we needed to measure also was the mass of weighing paper. So we have our mass already recorded for the weighing paper that is laying on the balance. Right, remember when you weigh out anything on the balance, for example, solid particles, you don't want to weigh directly on the balance. You want to have some sort of a receptacle to hold those substances. So we're going to use our weighing paper to hold our sodium chloride that we're going to be weighing out. Okay, and we're going to weigh out 1.20 grams of our sodium chloride directly onto the weighing paper, and then we're going to record what the mass of everything is. Okay, so we're going to use our scupula here, and we're going to gently add our NaCl, sodium chloride, until we've added 1.20 grams. All right, the next thing that we're going to do is we're going to measure out 20 milliliters of deionized water into our 50 milliliter beaker. So remember, we've already measured the mass of this empty beaker. We're going to pour in, using our squirt bottle, 20 milliliters of water into our 50 milliliter beaker, and then we're going to get the mass of the beaker plus the water. Okay, so in this section, we're going to be using a graduated cylinder to measure out a volume of water. So we have here a 50 milliliter graduated cylinder. When you look at it closely, you will see that the smallest graduation marks here are 1 milliliter, right? Which means that we can estimate to one place after the decimal point, or the 10th place. In other words, plus or minus 0.1 milliliters. So we're going to add into this, as accurately as we can, 25.5 milliliters of our deionized water. Okay, when we add water into a cylindrical object, what you'll see is that the water forms a curved surface called a meniscus, and we want the bottom of that meniscus to be at the level that we're trying to get to. So here we have added 25.5 milliliters of deionized water. So here's our 20 milliliters, there's our 30, there's our 25, and there's 26. So 0.5 would be right in the middle, and that's where the bottom of the meniscus is. So we have in here 25.5 milliliters of deionized water. We're now going to pour this into a dry and empty 50 milliliter beaker, and then we're going to make a measurement of the volume in here as well. Okay, and here you can see with the 50 milliliter beaker, our smallest increment, all right, is 10 milliliters. So we can really only estimate to maybe plus or minus 1 milliliter at the very best, right? So we can say, for instance, even though we used our graduated cylinder to measure at 25.5 milliliters, when we poured into this 50 ml beaker, we can only estimate and say that is probably around 28 milliliters. So this piece of equipment is called a Bunsen burner, and this is what we use if we ever need a flame, an open flame in the lab. The Bunsen burner is what we use. So we have here really, this part of the Bunsen burner is where the flame is going to be produced, and then connecting here with this tubing, the end of this tube will be connected to the gas outlet that is at your bench top, and we'll show you where that is in a second. So gas, the fuel, is going to come in through here, and it's going to go into the base of the Bunsen burner. This wheel here at the bottom of the burner we can turn to adjust the amount of gas coming in. We can also adjust this barrel here, we can move it to the left and to the right to adjust the amount of air coming in at the base of the burner as well, right? So the air here is going to contain the oxygen that we need. This wheel here adjusts the amount of gas coming in, methane and ethane, that's coming into it. So we can adjust our air to gas ratio to get different types of flames. We can get cold flames, relatively speaking. We can also get really hot and intense flames by adjusting the air to gas ratio on the Bunsen burner. Okay, so here we have the setup of our Bunsen burner. It's connected here to the gas outlet. So we're going to turn the gas on first. And then we're going to use our flint striker to light the burner. Okay, and you can see the flame here is sort of a yellow, billowy flame. And we can adjust the barrel of the Bunsen burner together with the base to give us a different type of flame. So for example, if I turn the barrel to the left, counterclockwise, I can adjust the amount of air coming in to get a different type of flame. So you can see now my flame is not yellow anymore. It has more of a distinctive and regular shape. It looks sort of conical. And what you'll notice is that there's an inner blue cone right about there. And that's the hottest part of this flame. So if you ever wanted to get a really hot flame, you're going to adjust the amount of air coming in, let lots of oxygen come in. We get this really intense flame. That inner blue cone, the very tip of the inner blue cone, is the hottest part of the flame. I can also make the flame bigger or smaller by adjusting the wheel down here at the bottom. If I wanted to change the size, right, I can turn it this way and you can see that I have a really small flame. If I turn it the other way, I have a much bigger flame. And again, I can turn the barrel clockwise now, and you can see the flame changes. It becomes a yellow, billowy flame. This is what we call a cold flame. We really don't use this type of flame in the laboratory. And the reason why it looks that way is because we've essentially cut off the air supply or the oxygen, so there's not enough air or oxygen to completely burn all the fuel. And whenever you're done with the Bunsen burner, you always turn it off over here at the main gas supply.